I don't want to go live anymore, what do I do?
No, go live. Definitely go live.
Just a second.
Starting. Aha. Receiving your content, your audience will see it in a moment. This appears to be working.
Yes.
We are live.
It just says PyData.
Yeah. So the YouTube link doesn't work. Aha.
I don't want to go live anymore. What do I do?
No, now the YouTube link works. No, we are live. We see.
We see Misha. So, Misha, you're a YouTube star.
Misha, we see you. We see your face on YouTube. Your audience will see it in a moment.
Okay, there's a small delay.
Yes.
We are live.
Perfect.
Okay, one cannot have Misha, you need to like mute the YouTube part.
I did it. It's gone. There's no feedback.
Okay, yeah, that was very entertaining.
If everything is fine, I'm going to leave. If at some point something goes wrong, I'm home. So just write me.
Okay. Thank you, Noah.
Thank you, Noah, so much. This has been a great help.
Alon, can you share your screen again so I can check what's happening in the YouTube stream?
Okay, I'm gonna run upstairs and get my phone so that I'm gonna tweet the link to the live stream on YouTube.
Wait, okay.
What do you see, Noah?
Well, okay, the live stream has everything but the slides. To be honest. Okay, wow. Interesting. I don't know how to take. Yes, now it has the slides.
Okay, I wonder how I can see what's like what's
well,
being
in
presented.
theory, you can open the live stream and in another and on the YouTube have feedback of what you're sharing.
Yeah.
But it will have delay.
Okay.
But on Zoom you don't see.
So just to be clear, right now you can only see the slides. You can't see the Zoom window, right?
No, I see.
So you mean right now I have the Zoom window overlaid on the slides. So can you read the slides clearly or not?
Yeah. We only see the slides. Yes,
okay.
We only see the
Fair
slides.
Enough. All right. Cool.
Nice. Okay, so I'm gonna start admitting people to the meetup. I hope they all behave well.
Okay, just to clarify, I go first, right?
Yes.
Okay. I have a hard stop. I'll need to drop it around 6:40, the latest my time, so 7:40 your time.
Okay, yeah.
So I'm gonna kind of power through the slides, and if anybody has any questions, then happy to take them by offline.
Alon, can you share your screen still? Because otherwise, it's just the YouTube stream is all of our faces, which is
got it.
Entertaining yet awkward.
True.
So how much time for each presentation?
As much as you want, 20, 30 minutes.
I said that it's about 30 minutes. I hope that's okay.
And how does it work with the questions?
Basically, however you want it to work. So we can, if you would like people to ask questions by asking the question, we can do it. Otherwise, we can have people on asking questions on the chat. And then so what we had before is we asked participants to ask questions on the chat. And then at the end, and then you can, if you want, Misha and I can interrupt you and ask the question, or if you would like to have the questions at the end, it's up to you.
Yeah, I'm happy to be interrupted.
Mm-hmm.
Yeah, if it's
maybe it would be best if we introduce this hand raise mechanism, which I tend to do during seminars. All the participants, they have this option of raising their hand. and this might be the best approach without you being too interrupted and us basically seeing that somebody wants to have a say.
Mhm.
What does it look like?
Misha, can you raise your hand so we see how it looks like?
Yeah, sure. Hold on. Wait a minute. Where's my hand raise?
What are the
Okay. There isn't this option. Why isn't there this option?
I thought it worked reasonably well last time, that the questions are just moderated through the chat. So people write their questions in the chat, and the moderator, in this case Noah or Misha, you then ask at the end of the talk the speaker those questions. This might work reasonably well also because we now have the live stream. So if anyone is looking at that, we're going to need to get some questions from the live stream also to the speaker.
How will people on the live stream ask questions?
There's a chat
there's a
chat on the live YouTube thing.
In theory, I could basically keep track of the YouTube chat, and Noah, you could keep track of, or everyone else could keep track of the Zoom group chat. And unless the YouTube chat will be too crowded, I think I could handle it myself.
Okay, yeah.
Okay, so Noah, should we do it like this, that you basically open it up, you introduce Alon, and then after that is done, I will basically MC Alon? Okay.
And okay.
With regards to questions, again, because of the time constraint, I'm happier to leave it to the end if there's time.
Yeah. I'm sorry. So, Alon, you would like to have questions at the end?
Yeah.
Okay.
I just want to make sure that I get through the slides before I have to drop.
But I'll tell the participants to post their question either on the YouTube thing or on the Zoom chat, and if we have time at the end, then you'll take the questions.
Yeah, for sure. And happy to take questions offline.
Okay.
Should we maybe also mute everyone, or how do we want to do this?
Yeah, we should mute everyone.
I can do it. Yes.
Misha, I'm going to try to help you with the YouTube comment page.
Yeah, thanks.
Okay. Also, I would like to announce a competition that the person who is farthest away from Berlin at the moment gets stickers. We will send them via post stickers.
So we had this same thing last time. Am I sorry? Yeah. Furthest away, how? Geographical distance or ping time?
Geographical distance.
I thought ping time was a pretty good proxy. Much more suitable for PyData.
Okay, am I currently in the lead or is there someone farther away?
From London. Last time we had.
Yeah, I'm pretty sure there's someone further away than London.
Yes.
Hello, I'm from Argentina.
There we
Oh,
go.
yes.
No,
We
Pablo is
might
in Iran.
have a problem with like someone from Argentina and then someone from an roughly equal distance away in some other country in a completely opposite direction.
Wow.
I guess in that case we can send both of them some stickers.
Okay.
We
Okay,
can
it's-
also have a competition for the person with the most awkward time of the day.
Okay, we have Vietnam and Tunisia. India.
Oh.
Oh, I'm gonna need to get some. Is this Noah? Are we talking straight line distance?
we talk a great circle metric, I would say.
Euclidean metric, right?
Oh
No, not
man,
Euclidean, it's like-
is there some calculator thing I can use for that?
Chile, wow, Chile is getting Google Maps.
Will Google Maps
let's
do that
say
for me?
Distance. Okay, I found distancecalculator.net.
Okay.
And I'm putting
Distancecalculator.net.
Berlin to, let's say, Buenos Aires is 11,910 kilometers.
Actually, for more precise position, I'm from Santa Fe, Argentina.
I'm sorry. Let's see if it brings you closer or further away. Santa Fe, Argentina. I'm afraid there will be a million Santa Fe. It gave me Santa Fe, USA. I'm very sorry. It's kind of an...
Yeah, Hanoi is 8,300 kilometers.
No, Buenos Aires.
Buenos Aires is further away.
Yeah, Santa Fe, I'm sorry, it's closer than Argentina, than Buenos Aires, but you're still in the run.
I think it's far from Buenos Aires, I think, yes.
So Santa Fe, Argentina is 11,779.19 kilometers. But so who was from Chile? That should be further away.
Yeah, there was the person.
Kazakhstan, Crete, India, China, Kenya.
Oh, we should change the rules of the game to calculate the distance between where you are right now and where home is.
Oh, yes, but we and we send one sticker to you and one sticker to your parents.
Yes, my parents really do need a few more PyData stickers for their laptops.
Okay, I think we will officially start, and we will also officially announce the game, the contest. And so, hello everyone, and welcome to the PyData virtual May meetup. I hope everyone is healthy and happy and enjoying their virtual life. And we were just discussing that it seems that having virtual meetups really allows us to interact with people who are also not based in Berlin. And in this spirit, we announced the competition. The person who is farthest away from Berlin in kilometers is gonna get some PyData stickers. So if you think you may be in the run, so far we have some people from Argentina and Chile. So please send us either in the Zoom chat or the YouTube chat the city where you're based. And if you are the farthest away, we will ask you probably to send us an email with your exact address, because otherwise we can't really send you anything.
Well, otherwise we'll just send you virtual stickers.
Yeah, so if you want a real sticker, you will need to email us your exact address to our PyData@berlin.info. We will also write it in the comment section of the meetup page. Other than that, one more announcement.
Sorry, just Noah, that the email address is info@pydata.berlin.
Yes, I'm sorry, to the email info@pydata.berlin. Yes, and we will write it, of course, also in the meetup section, in the comments of the meetup page. One sad announcement that maybe some of you already heard, the amazing conference, Python Day and PyData Berlin 2020 has been unfortunately canceled. As we understood, we won't be able to have it in the form and shape we wanted it to be this year. We are working very hard on having a 2021 conference, and we will release the dates once we have them. And we also would like to remind you that our code of conduct still applies also online. Please be kind to each other. And you can freshen up on the code of conduct on the NumFOCUS website. And if you're watching via Zoom, please feel encouraged and free to turn on your video so Alon can see us and know who he's talking to. If you would like to ask questions, please write them on either the Zoom chat or the YouTube chat. And Alon is a bit limited with time, so if he has time after his presentation, he will answer some of the questions. And if he doesn't get it, he said you can contact him on Twitter or GitHub, and he can take the questions offline. So without further notifications, let's start with Alon's talk about getting an edge with network analysis in Python.
Thanks, Noah. Can everyone hear me all right? Great. Well, thanks for the intro. Noah and I have been talking about having this talk for about 6 months or so. I was looking forward to doing it in Berlin, but unfortunately, that's not going to happen. So I'm doing it from a very hot bedroom in London. And today I'll give really a brief introduction to network analysis in Python. And yeah, as Noah mentioned, I'm a little constrained in time. So anything that I don't get to at the end, then please feel free to ping me on Twitter, LinkedIn, email, and so on. I'm happy to take questions offline if we don't have time at the end. So let's just jump into it. A little bit about me. I'm a senior data scientist and a data science lead at Deliveroo, which until recently was available in Berlin. And other than that, as mentioned, I'm London-based, originally from Tel Aviv. On a personal note, I haven't had a haircut in 4 months due to Corona. And sometimes I tweet interesting things on Twitter, so feel free to follow me at Alon Nir. So today, as I mentioned, a quick introduction to network analysis. We are constrained in time. Network analysis is a huge topic, and you can find on YouTube workshops from PyCons and PyData conferences, which for like 3 or 4 hours at length, just to introduce people to network analysis. And obviously we have 25 minutes or so. So we are really going to touch the bare bones of network analysis. So my agenda for today, my objectives are very, very simple. I want to show you that network analysis is extremely useful. And I also want to show you that it's really easy to get started. Yeah, so our plan is simple. We'll discuss why you should learn about network analysis and a few motivating examples. We'll give the very brief, bare bones theoretical intro. We'll analyze real data with Python, so you can see that it's very easy to get started. And time permitting, we'll explore more useful and interesting examples from real life. What we won't do in the interest of time is to dive deep into the theory and everything that there is to learn, because there is a lot to learn and it's really fascinating. Again, for simplicity, there will be no math, no metrics representation, and no Greek letters whatsoever. We won't dive deep into the theory behind the different things that we'll see. I think what's important to know about network analysis, or what's cool about it, is that sometimes the result we get are intuitive for the human brain, but they are very complex if you want to devise an algorithm to do it in an efficient way. And finally, and most importantly, we are not going to use the C word today. It's tempting when you have a network analysis talk to discuss about how viruses spread and everything like that, but I feel like the world has had enough of that in the last 2 or 3 months. And I think that the last thing you want to do is to hear about it some more from me. So we will not use that tool today. Yeah, so next. Quick kind of like intro as to why and what you can do with network analysis. First of all, I think that as data scientists, we come from various backgrounds. Myself, I come from economics. I have people in my team that are structural engineers and chemists and biologists and a few physicists and a physicist that's, that his specialty is in lasers, which is extremely cool, but, doesn't have anything to do with data science. And network analysis is just one of those things that it's extremely useful, but people don't really learn about it when they transition into data science. So I think it's something that's kind of a secret weapon, but it shouldn't really be a secret weapon. Furthermore, I think that as humans, we tend to think linearly or in like tabular form. But then if you add network analysis onto that, or the network representation of data, then you get you kind of unlock a new dimension where you can really learn a lot more from the data sets that you have. And finally, it's just cool. So let's be concrete here. Let's talk about actual problems that you may use network analysis to solve. And these are actual problems, and you can get paid to answer these problems. And I know that because I was paid to answer these problems with network analysis. So let's assume that you're a product data scientist for a peer-to-peer payments app. I'm not sure if there's something like that in Berlin. In the US, there's a big service called Venmo, owned by PayPal. Basically, I can Venmo you some money, you can Venmo it back. In the UK, we have Monzo, which is again the same basic idea. Think about like WhatsApp, only instead of sending messages, you send some money. And then you are a data scientist, and then a few people around the business ask you several questions. The customer service team could ask you, we have a bunch of customers calling us or sending us support requests. Whose call should we answer first? Who should we give white glove treatment to, and who can we deprioritize in the list? Which is a very concrete and good question. The marketing team could tell you, hey, we've got some money for an influencers campaign. Can you tell me who the influencers are? So we could spend that budget efficiently. The product team could ask you, hey, who are our power users? Who do we want to kind of keep in mind when we design a new feature, for example? And the customer research team, again, should ask you questions like, hey, who do we want to interview in the next time we do any customer testing? So actual real questions. And of course, there are many other use cases in real life. Pretty much everything could be models and networks. So of course, in real life, there's a lot of research and a lot of info about how you can use your finding a job is actually a network analysis problem. Finding a spouse, anything on Google really is just one giant network of data. How you can use network analysis to detect bot or troll networks on Twitter. You can detect people on Reddit that kind of are cheating with karma, with the upvote system. If there's a financial crisis, like in the 2008 financial crisis, the Obama administration, to the best of my knowledge, used network analysis to decide which banks to bail out and which banks not to. You have personalized recommendations, which is a huge use case for network analysis. It's pretty intuitive. If you like a certain movie, for example, and a certain film, and then many people who like that film also like these other films, and we can recommend another film for you and pretty accurately. And most importantly, this is an example I always go back to: voting in the Eurovision can be modeled with network analysis, and it has been modeled with network analysis. And given the time, we'll actually see it live in action in a very, very interesting website. So what is it? You can go to Wikipedia and read this incredibly interesting description, which is not very user-friendly. In one very common sense of the term, a graph is an ordered pair, V and E comprising a set, and so on and so forth. That's not very user-friendly. And guess what? It's even less user-friendly when it's in German, because I don't speak German. So if we want to keep it simple, we can think of networks as just points and lines. If you can draw a conceptual relationship between any two things, it's likely that you can model them as a network. So just a few examples, people obviously are an example of a network because we have friendships, we follow each other and so on, we communicate with one another. Companies trade with one another. You can think even of like bus stops as networks, points on a network, and then buses that go from one stop to another from that network. Similarly, a bicycle sharing scheme, countries, as we mentioned, they exchange Eurovision points, and even Wikipedia articles. Pretty much anytime I open Wikipedia, I find myself kind of opening Wikipedia just to read this one article, but then I find myself clicking on a bunch of links and opening more and more tabs to read other things. So different articles on Wikipedia could be modeled as a network, and then they are connected from one article to another. So that's essentially a network, which is pretty cool. And there are all sorts of like interesting exercises on Wikipedia about, like if you're looking for a homework assignment from this lecture, is like trying to figure out, how many steps does it take to get from point A to point B on Wikipedia, from an article about Abraham Lincoln to an article about TikTok. Right. So the obvious example that we'll use today, just intro ourselves to the concepts of a network, is Facebook, which is something that we all know and use. So we have this blondie guy, and there's another blonde person, and they are connected on Facebook. Great. So those are the points and lines. And then obviously, if every one of them knows more people, and there are more relationship between those people, and that's a very, very simple, basic network that we just created. So far, it's pretty straightforward, I think. So apparently, as it turns out, those points and lines actually have real names. In computer science, the points are called nodes, and the lines are called edges or links. In math, it's vertices and edges or arcs. In physics, it's sides and bonds. And in sociology, it's actors, which is cool, and ties or relations. And a lot of the work around network analysis actually comes from social network analysis. There's a very famous paper by Mark Vettel, which about
yes,
exactly about the strengths of weak ties. It's been cited more than 56,000 times, so it's a pretty popular paper. We'll be using nodes and edges because that's just what I'm used to. Very, very high level, the main types of networks are directed and undirected. Undirected are like friendships on Facebook. So if I'm Noah's friend on Facebook, Noah is also my friend. That's undirected. And then there's things like Twitter, for example, or Snapchat or Instagram or TikTok, where, if I follow Noah's TikToks, then it doesn't necessarily mean that Noah follows mine. And so on. There are other things like multigraphs and multi-directed graphs, but in the interest of time and confusion, we won't get it. So Facebook, if we go back to our Facebook example, Facebook is an undirected graph. And again, applying our new terminologies, and these are the nodes in blue, and these are the edges in teal. At this point, I'd like to add just one more concept into the mix, and we'll see that with these three things, nodes, edges, and paths, which is the next thing that I'm going to introduce, we can do some pretty cool stuff with network analysis. So paths are just a collection of edges from one point to another point, from one node to another node on the graph, as long as there's no repetition. So any route, any walk from one node to another, as long as there's no repetition in edges or in nodes, that's a path. So this is one path in purple. This is a different path, and yet another one. So quick recap: nodes, edges, paths. So far, I think so good, right? Cool. I hope that's not Corona. No. Okay. So this is PyData. So let's do it in Python. NetworkX, an amazing library that is very comprehensive. It has a very friendly API and documentation. And it's like, if you need to get started in network analysis, do it with NetworkX, because this is the most robust and friendly library there is out there. It doesn't scale immensely great for like very, very big graphs. You can do it with other tools, and the visualization for large graphs isn't really good either. And there are other tools you can use like Snappy, GraphTool, iGraph, and Gephi, which is not actually Python. But so the dataset we'll explore today comes from Venmo, which is the service I mentioned earlier. I'm going to try to open a link live in real time, and hopefully it will actually work. Okay, this is Venmo. Okay, as I mentioned, Venmo allows you one person to send another person money on an app. And the interesting thing about Venmo is that those transactions are actually public. So you can ping an API, or if you, for instance, look for long enough in dark corners of the internet, you're likely going to find a large data set that you could analyze. So I'm gonna work some magic, and I'm gonna try to do a bunch of stuff at the same time. Let's try to, here we go, one step. Let's stop the script here real quick. So you could see that in real time, things happen. Okay, apparently, yeah, it's not gonna happen. Here you go. Right. So in real time, this is actually Venmo's website right now, and I just stopped the script from updating it. But you can see transactions, you can see connections that have happened on Venmo. So you can see a person named Sky F paid John G a certain amount of money for virtual coffee date, which is great. You can see that Julia S paid Pluto S to help with your bills this month, and so on. These are actual transactions that just happen on Venmo. And what we can do, we can analyze that. So let's hop back to the deck for just a second. And actually, let's go to the Jupyter notebook. I'm sorry, I'm still trying to figure out how to interact with Zoom and not have my computer crash at the same time. Hopefully the font is large enough in the notebook. Cool. So this is a snapshot I took from a while ago from Venmo. You can see, if you squint really hard, you'll see that Leonard paid John, and Hunter paid Brian, and Erica paid Monica. And this is very, very easily represented here as nodes and edges. And let's actually do that in pure Python, or in Python with NetworkX. So let's.
Alon, actually the code font is a bit small. So
all right, how about now?
Getting there.
Really? Okay. Okay, it's gonna be a little challenging, but I'm sure we can make it work.
Okay, that's fine.
Okay, this is like super blind. Okay, cool. So just import NetworkX as NX, because that's a convention, and then a bunch of other stuff like pandas and matplotlib and collections and so on. So in order to create your first network with NetworkX, here's what you need to do. You need to assign G to be nx.graph, or call the graph method from NetworkX, and you created a network. Congratulations. In NetworkX, anything really could be served as nodes. It doesn't have to be, for instance, just an integer. It could be a bunch of stuff. And now let's populate the graph, okay, that we just created. And we will pass, in order to populate the graph we created with this data here, we'll just pass it as a list of tuples. So as we saw earlier, Leonard paid John, Hunter paid Brian, and Erica paid Monica. We'll use the add edges from method. Bang, done. And if you don't have to believe me, let's just visualize it. So there is a very useful draw NetworkX method. Really, I mean, basically you pass G, which is the network, and then a bunch of other parameters just to make it look nicer, but you don't need to spend too much time thinking about it. And you can see this is exactly what we saw up there, only this is from a network we just created, use network X. So bam, within like 2 minutes, we created our first network, which is nice, but it's not super exciting because it's a stupid small network with 6 actors and 3 edges. So let's do it in kind of a larger scale. Again, as I mentioned, if you look long enough on the internet, you will find data sets for Venmo. And what we'll do is use a larger data set, which is a very large graph. And then this is the plan. We'll start from the large data set. We'll break it down to smaller subgraphs. We'll zoom into one of the subgraphs. And in that one, we'll discover communities. And we'll discuss what communities mean in a little bit. And then after we find the communities, we'll actually look at interesting individuals in those communities. Sounds good? Thank you, Noah. Cool. So let's load a bigger data set. We'll do it with pandas. And here you go. So this is, there are 600,000 records. And basically, we have sender ID and receiver ID. Sender ID is the person who sent money, and the receiver ID is the ID for the person who received the money. At this point, I should say that all the data you'll see today has been obfuscated, and anonymized. So there's nothing here that that will be identifiable for the people who were actually in the original data set, but the structure of the network is preserved because I just obfuscated the actual IDs and other data. So at this point, what you can do is you can use a from pandas edge list method to populate a network with your data frame. You just pass the data frame, you define what the source is, who sent to whom, what the target is, who received the money, or in any other case that you may have, and then you will create actually a digraph, which is a directed graph, what I mentioned earlier, which makes sense in the Venmo case because the fact that I sent Noah money does not necessarily, unfortunately, mean that she sends it back to me. And I'm sorry, Noah, if I'm using you too much as an example because you are the only thing from Zoom I can see right now. So unfortunately for you, I'll have to go back to you quite a bit. Yeah, let's run that. It will take a little bit of time. Fingers crossed. Fingers crossed. There you go. Okay, so we have, we mentioned that we have 637,000 records. So those are the transfers, but those transfers occur between about 710,000 different individuals. Okay, and we see that there are actually also 0 isolates. So these are nodes that don't receive anything or don't send anything, which makes sense that we don't have them in our data set because why would they be there if we have a transactional data set? Cool. So if we wanted to visualize that large network, and remember what I told you about network X having shortcomings in the visualization of large networks department, this is what we'll get. The red dots are the nodes and the black lines are the edges. So I don't know what about you, but for me, this is not very useful. So what can we do? So we can use other, we can visualize it with other tools and figure out a way to do it, or we can, for the sake of this presentation, we can kind of zoom in on one subgroup within that network and kind of visualize that if it will be like smaller and more user-friendly. And let's go with that because I'm more concerned with like an intuitive understanding of like a small scale network rather than trying to really make sense of a huge graph. Cool. So let's find those subgroups or subgraphs inside this big giant graph that we created. Those things are known as connected components, and connected components are basically subsets of the original nodes that follow 2 rules. First of all, there is a path, which is the word that we learned earlier, between any 2 nodes in the subset, and there is no path to any other node elsewhere. So in the very basic Facebook example we saw earlier, this is the entire graph, and it's also a connected component, because if you wanted to reach one node from another node, there is a path. You can find a path. So this is one big connected component. However, if I came with a big pair of scissors and I sever the connection here between Blondie and Blondie, then I would get two connected components, okay? Because here is one connected component, because I can get from one node to another, there is a path, and here I can get from any one node to another, there is a path. But there is nothing in between. There is no path to another node. So these are self-contained and these are self-contained. And in networks terminology, this is called a connected component. As you can imagine, there is a built-in method to do that in NetworkX. I don't need to run that because it's a stupid example. We will use something that's called a weakly connected component. I'm not going to get into the intricacies right now. I don't want to confuse people too much, but trust me, it's for the sake of argument. So weakly connected component, we are going to run that for a bit. It's a little intensive. And we'll see that we generate some stats, and we'll see from that large network of 700,000 interactions, we found a bunch of connected components, and the biggest connected component inside that network has 18,630 members, which is pretty cool, because if you think about it, it's likely that many people of those 18,630 don't know each other, but there is a path. So if they really wanted to transfer money if they found a random person on the street who's in that 18,630, they could find a path, which is fairly cool. And it's also fairly cool that we could find this huge community lurking inside the bigger graph. And if you kind of plot the top 5, we'll see that the second biggest one is 1,800 strong, and so on. It goes down pretty rapidly. Now, as a presenter of a Zoom talk, I have the benefit of cherry picking the data points I wanted to handle. So I'll do just that. This is one connected component that I cherry picked from the data, and I'll use that. These are all user IDs, and I'll use that to create a subgraph. A subgraph is basically a subset of the original nodes, and NetworkX knows how to handle that. So if we'll define G sub, which is G subgraph, and we just take the original graph, G, the big one of 700,000, and we use the subgraph method, and we specify which nodes, NetworkX knows to take those nodes and all of the connection, all of the graph structure between them, and which is very useful. So we see that there are 40 nodes, there are 78 connections between them, which is much more manageable. And actually, I'm going to try to visualize that again with the same draw method. But given that I zoomed in like 200%, I'm not sure what we're going to actually see. OK, it's manageable. It's manageable. It's not too bad. Now, this is, even though it doesn't fit the entire screen, I think maybe if I'll do this, it will. Here you go. You can see that it's much, much more user-friendly and much more interesting than the other things that we saw earlier. OK, so cool. I'm going to jump back and forth. Let's add user IDs just so we can see that it's easy to do so. We just need to add with labels keyword. Eventually, it will come up. I didn't appreciate how much Zoom slows down your computer. OK, so we added user IDs. Great. It's not very useful, so let's add the names. I'm going to read another data frame that has plots that connects user IDs to first name and gender, for example. Doesn't really matter. The point here I'm trying to make here is that you can also, in addition to the nodes and edges, you can also apply attributes to your graph. And that's useful, like if you want to do something a little bit more complicated. So I added the names. You're probably not going to see them very clearly. That's fine. You'll see. We'll make it better in a sec. Let's just take a quick break and kind of see where we are. So we started from a large network, which wasn't manageable inside our notebook for today. Then we decided to zoom in on one subgraph, which is all of these nice people. Now, what we're going to do next is we are going to detect communities, and we are going to zoom in on individuals. So what do I mean by communities? This, and hopefully you'll see it clear now, this structure is interesting, and intuitively, if we kind of had to eyeball it, we would say that we can detect communities ourselves. All of these people over here seem like a community of their own, and these people look like a tight-knit community, and these people, and these people, and these people are all kind of separate communities. So if we had to eyeball it, that kind of makes sense, but how do we do it with Python? Let's head back. It's a little complicated. Again, as I mentioned, some of the algorithms to actually do something in Python are quite sophisticated. I'll say that intuitively, the way to think about communities is that, you have your own group of friends. Some other person has their own group of friends, and you don't know that person's friends, and your friends don't know that person's friends. But I am aware that there is another person that I kind of know that has his own friends. So unlike connected components, which were completely separate entities, when you look at communities, then there are basically tight-knit groups that are weakly connected to one another, that there is some knowledge of one another, but they don't really hang out. I hope that makes sense. The way we'll actually do it, the way we'll actually detect communities in our subgraph is by cheating. We won't use something built in NetworkX. We'll use a library called Python Louvain after the algorithm. And yeah, we ran it. We found them. It's fairly straightforward. And then what I'm doing here is I'm actually going to plot the same network we saw earlier, but I use the data that we found in the communities. And then every community that algorithm just detected will get a different color. So let's see what I mean. There you go. Hope you can see it. Again, it's got a little bit of a problem here when I had to zoom in. But if you really squint very, very hard, you'll see that all of these people that we saw earlier, that we said, hey, this kind of look like a community. Well, they are. They're yellow. They got their own color. They're yellow.
Alon?
And all of these people. Yeah.
There's a question on YouTube, which might be interesting right now. That person would like to know if we can determine the width of the edges by some metric. I'm not exactly sure what this person means, but does it make sense to you?
It does make sense to me. I'll come back to it at the end. It's a great question, and I kind of mentioned it before in the deck. I said there's also like multi-graphs and stuff. So multi-graphs basically kind of refer to when a relationship between nodes could have multiple edges. So for instance, I can send Noah money on Venmo several times, and then you can kind of look at the number of times I sent Noah money or the amounts, and kind of determine that our relationship may be stronger, and kind of give a weight to the edge, which will be proportional to the either the number of times I send her money or the total sum, stuff like that. But I'm really trying to keep things simple. It's a great question. It's the next step, definitely. But I'm really doing the bare bones here to try to keep the conversation going. And I do have a hard stop soon, so I'm just trying to power through the information, if that's all right.
Okay, thanks.
Cool. So just to recap, as we said earlier, we're kind of seeing that the algo managed to detect what we saw by eyeballing the data, that this is a community by itself, and these people are a community, and these people are a community. What we managed to kind of see intuitively, so did the algorithm. And now here's the question. Here's a question for you. Who are like the important nodes in this network? And again, eyeballing it, you can kind of say, there's a few interesting individuals here that kind of get a lot of, they're in the center, and then they get a lot of arrows that come in and out. They have a lot of edges. Let's do it in kind of in network analysis speak. So there are a lot of ways to score or rank nodes. And there is no one right way. It depends on like the context and the goal. There is one of the basic and most naive ones is called like degree centrality, and you can also think about it as like in and out degree centrality, which goes back to what that person from YouTube just asked. So basically, if I have a lot of nodes of a lot of people sending me money, then maybe I'm more important than someone who just have one transaction on Venmo. That's a very naive way to look at it. And there are a few things that are a little bit more complex, like between centrality, which we'll see in a bit, or PageRank. PageRank is the algorithm that was developed by Larry Page and Sergey Brin, and how they ranked each website on the internet and kind of managed to kind of plot them on the network and figure out which website is more interesting than another. And then they built a small company called Google, and the rest is history. Between centrality, which is one of the metrics we'll use just now, is very interesting. So just kind of to give you an intuitive sense of it, if we talked about paths earlier, we can think that, whenever we want to get from one node to another, we would like to find the shortest path, because why go long if you can go short? And what between centrality basically means, in kind of intuitive way, is that nodes that are more prominent that belong to more shortest paths between any two nodes, these are more important nodes, which kind of intuitively makes sense. These are the connectors or the influencers or the kind of the strongest people in the network, because everything goes through them. And network X obviously has centrality measures, so you need to call network X centrality between a centrality. You'll get scores for each node, and then if we kind of go back and just plug the scores that we just calculated into network X, then we can visualize it. Again, it will take a second to run, and we can see that Tito and Lincoln over here, Julius, Todd, are more interesting or more important nodes depending on the between centrality. So the larger the node, the more important that person is. And in the interest of time, I'm just gonna kind of breeze through this, and we're gonna do the same with the PageRank algorithm. And we can see that people kind of in the center of the network are relatively more important than people on the side. So just to tie it back to our original questions that we asked, if I'm the customer service team, whose customer service call should we answer first? And the answer is one of those important nodes in the middle. Because if I look at just this guy, Alberto, if I give him, obviously as a company, I would like to give everyone good service, but there are constraints. So if I have two calls, one of them is from Lincoln, and one is from Alberto, I would like to answer Lincoln's call first. And if I had only 10 pounds to give in compensation, I would like to give Lincoln all of that 10 pounds probably, because if Alberto doesn't use the app anymore, that's fine, because he only is connected to one person on the network. So the collateral damage of losing Alberto is just losing one person. But if I give Lincoln a bad customer experience and I'm losing him, then all of these connections will be severed. So I'm at risk of losing more individuals. And similarly, the marketing team wanted to know who the influencers are, so we can see kind of from different centrality measures who are the influencers. And likewise, customer research team wants to know who to interview, and product team wants to know, like who are the beta testers, or who should we keep in mind when we're launching or we're kind of thinking about new features. Then those power users are often the kind of people you want to interview, because they would have interesting insights in what make the product kind of be adopted by more and more people. So these are the people you need to keep in mind. Now, and I'm sorry I'm rushing through things. I do have a hard stop. So I just want to wrap up nicely. And I'm going to skip through these. There is a Eurovision voting examiner. You can see the link right here. I'll publish it. Basically, it looks at all of the Eurovision votes along the years and sees, which countries give votes to which other countries. And you can see blocks. You can definitely hit blocks. And I think that you can guess what the blocks look like yourselves. Because if you have ever seen a Eurovision Song Contest, you know that it's a rigged game. Let's be honest, in my opinion. Cool. So closing remarks. Okay, we answered a real world business question using network analysis in just a few minutes. Okay, which is pretty cool. We saw that it's powerful. It's widely applicable. We barely scratched the surface, so there is a whole lot to learn. And I encourage every one of you to go, and I will publish in the coming days. I will publish a lot of reading material and other sources you can read to go and study it even more, even read the documentation on Network X, because that's even another good way to kind of familiarize yourself with more and more things that have to do with network analysis. And yeah, and Python is great. So I'll post a lot of next steps and links that you should go to. I'll also kind of try to share the slides and code in some manner. I'm not sure exactly how just yet, but I'll kind of reach out to Noah when I have the exact details. So you can follow me on Twitter, and I'll probably also post it there at some point. So with that, I really thank you for the opportunity. I think it's really, really cool that we managed to talk when there are people in Indonesia and Buenos Aires, which is like, could not have anticipated that. So thank you. And with that, I am going to have to rush to another call. So thank you very much, everyone.
Yes, thank you, Alon, very much. We are gonna try now to have a break, which is some 5 to 7 minutes where we should interact with each other. For this, I'm gonna do first two things. I will pause the recording and I will stop the live stream. So if you are joining us on YouTube, please, we will be back in 6 minutes. So at 7:55 Berlin times, which is 6 minutes from now, we will